Welcome back. Today we're talking about applying properties of similar triangles, and one of the things that I want to show you is in this picture here. The use of perspective in art is really huge when we're talking about similarity, because if you'll notice, this little girl looks like she's putting her hand on top of this helicopter, but really it's because we're playing with the perspective, okay? And so this helicopter is really farther away, but it's smaller, and so it looks like that she's got her hand on top of it because she's in the foreground. A lot of artists use this kind of perspective to kind of create an effect when they're doing art. And so we're going to look at that later in this chapter, but that's one of the ways that we can use similarity. These are not necessarily triangles, but art is a way that we can incorporate similarity into the things that we're doing. Okay? And so what I want to look at is this lesson is about using the properties and specific theorems to try to find lengths in triangles. Okay, and so let's go down here and learn about the first theorem. The triangle proportionality theorem. If a line parallel to a side of a triangle intersects the two other sides, then it divides those sides proportionally. Okay, and so this triangle has a line that's parallel to one of the sides, and I've told you that EF is parallel to BC. So it divides the sides proportionally. The conclusion that we can make is this. Proportionality is about having two fractions. And so the fractions that I'm going to write here are fractions using these sides. Okay? And so the top part over the bottom part is equal to the top part over the bottom part. That's proportionality in this triangle here. Okay, and so this is going to be really useful because you know that we've seen a lot of triangles that look like this. Let's use that to find a segment length. Here's two examples. Okay, the second one that's highlighted is going to be for you, but let's try this first one first. If I want to find CY, I'm going to put a question mark there because that's what I'm going to find. Well, I notice I have a side that is parallel to a line that touches the other two sides of a triangle, and so I can set up my proportionality. Well, what I'm going to say when I set up my proportionality is I'm going to say 9, the top part of the triangle, over 4 is equal to the top part, 10, over my question mark. So 9 times what I don't know is equal to 40. Divide by 9. Divide by 9, and what I end up with is 4 4/9, because 9 goes into 44 times, it's 36. I've got 4 left over, so really this is 4.4 repeating. Okay, so that's a very simple way to solve for the length in a triangle. Let's see if you can try the next one. It's a little bit different because it's turned, but I think you can try this one, so bring that one to class when you come. Okay? Let's move on to the next theorem. Once again, it's okay to pause. Be a critical watcher of this video. It's theorem 742. Converse of the triangle proportionality theorem. If a line divides two sides of a triangle proportionally, then it's parallel to the two sides. So what I'm assuming here is that these sides already have this relationship, so I tested that. Well, the conclusion that I can make then is that line EF is parallel to side BC. Okay? And so that's what this sign is saying. That's what this theorem is saying. Test the sides, then the lines can be parallel. Okay? So we're going to verify that segments are parallel in example 2. We're going to verify that these sides are, or that these lines are parallel. And so I need to actually add this in. So I want to see if these two lines are parallel. So how am I going to do that? Well, I'm going to test the sides. So I'm going to say 42 over 21. And I'm going to put an equal sign and a question mark because that's what I'm testing. Is that equal to 30 over 15? Well, this reduces to 2 over 1. And is that equal to 2 over 1? Yes. So MN is parallel to KL. Simply test to see if the sides are proportional, then those lines must be parallel. Okay? See if you can try this next one. It's going to be a little bit trickier because I didn't necessarily put it in, but go ahead, you can write in these values. So AC is actually 36 and BC is 27. See what you can do with that. Bring that one to class. Okay? So these two things that we've so far discussed are really not too mind-blowing. They're really just dealing with proportionality as we've done it before and using those cross products to try to solve for a couple things. Okay, so that's applying similarity 1. Okay, and so that's it so far. Come back for the second part next time, and thanks for watching.